For the next 2 weeks, we're going to be looking at fertilisers. To begin with, we need to be able to name the elements required for plant growth, and then we're going to look at fertilisers and how to make them and the purpose of them. Because we've got an ever-increasing population in the world, means that more food is required. This means that more plants are required to be grown, and fertilisers are used to help grow plants efficiently. When we continuously use the same soil and the same fields for growing plants, when we harvest these plants, what it does is it removes the nutrients from the soils. So we're required to use fertilisers to replace the nutrients in the soils. We've got 3 essential elements for plants to grow, and these include nitrogen, phosphorus and potassium, and we'll find these elements in the form of nutrients. So fertilisers are actually made up of compounds that contain the nitrogen, the phosphorus and the potassium, and they can contain these elements in different concentration because depending on what plant you're growing, depends on what elements is required. Now it's important that these compounds must be soluble. Okay, that's quite a key question to come up in the exams. You need to be able to look at the table of solubility in your data booklet to see that the compounds are soluble to be used. So this is a typical exam type of question. So which of the following salts would not be suitable as a fertiliser? We've got 4 options, so it's sodium nitrate, ammonium nitrate, ammonium sulfate and aluminium phosphate. So what we need to do is we need to use a table of solubilities and to look up each of these compounds, and because it says not, one that's going to be insoluble. So if you look up each of the compound in question, you go down to aluminium along to phosphate and you see that that is insoluble. Now because it's insoluble, that's going to be the answer. It's not suitable as a fertiliser. What I want you to do now is have we go down this question, have a think about it, write down your answer and email the answers to your teachers when you're emailing your work to them. Ammonia is a very important nitrogen containing compound, so we're going to look at the properties of ammonia and the production of ammonia and how to make it. You might be asked to draw a dot cross diagram showing how the atoms and ammonia bond together. Just going back to Unit 1 and the bonding. So these are covalent bonds, the sharing of electrons. The nitrogen is group 5, so it's got 5 alpha electrons, it's got a valence of 3. It needs 3 hydrogens to make it stable. These 3 hydrogens will come in and it will share its electrons with ammonia and produce 3 covalent bonds. So the ammonia fountain experiment is a good demonstration to show you how soluble ammonia is in water. It also demonstrates that when ammonia dissolves in water, an alkaline solution is formed. So ammonia contains nitrogen, so it makes it a good feedstock for making fertilisers. Now ammonia dissolves well in water to form an alkaline solution. It also has a very distinct pungent smell. The Haber process is a process to make ammonia. So what we're going to be learning in the next few slides is why the Haber process is so important, the equations involved in the Haber process, the effect of changing temperature in the Haber process, and also the catalyst involved. So as we said, the HABA process is a process for making ammonia. So it takes nitrogen from the air, hydrogen from natural gas, mixes these two together at moderately high temperatures, high pressure, uses an iron catalyst, and produces ammonia. So we'll run over what we just said in the previous slides. We get nitrogen from the air, we get hydrogen from natural gas. Two reactants are mixed together in a compressor. It's passed through an iron catalyst, high pressure and a moderately high temperature. We condense. Remember, condensing is a process from turning a gas into a liquid. We condense ammonia by cooling and we get liquid ammonia. Any unreacted nitrogen and hydrogen can be recycled back through the process. This process is reversible, so it can go in both directions. This is indicated by your double-headed arrow. It's an exothermic reaction, so it gives out heat. If a too high temperature is used, the ammonia will change back to nitrogen and hydrogen, so it's reversible. So the high temperature favours the reversible reaction. So this is why we use a moderate high temperature, but not too high a temperature. It also explains why not all the hydrogen and nitrogen are changed into ammonia, and why it's recycled back, because it's reversible. So we've got this little double-headed arrow that means that the reaction is reversible. But at the same time we're making the products are breaking down back into the reactants again. At low temperatures the reaction is too slow, but at high temperatures the reverse reaction is favoured. So the reverse reaction becomes more dominant. This is why we use moderate temperatures.